Black holes are real. We've seen them. We've photographed them. We've measured their gravity, their spin, their shadows. But what if every black hole has a mirror? Not a twin, not a cousin. Something opposite. Something that doesn't pull things in, but pushes everything out. A white hole. A cosmic explosion that never stops. A place where nothing can enter, only leave. And yet, no one has ever seen one. No telescope has captured its light. No instrument has recorded its pulse. It exists only in equations. In theory, in the quiet corners of physics where imagination still dares to ask. What if, in 1916, Carl Schwarzschild solved Einstein's equations for gravity around a point mass? His solution described a region so dense that not even light could escape, a black hole. But the math didn't stop there. Hidden inside the same equation was another solution, a time reverse version, where instead of swallowing matter, it spits it out, where the event horizon works backward, where the future is not an end, but a beginning. This was the white hole, a theoretical object born not from observation, but from symmetry. If time could flow forward into a black hole, why couldn't it flow backward out a white one? For decades, physicists dismissed it as a mathematical curiosity, a ghost in the numbers. But the idea wouldn't die. Because if the universe allows black holes to exist, shouldn't it also allow their perfect opposite? A white hole is defined by one rule. Nothing can fall into it. Not dust, not gas, not a star, not a spaceship, not even a single photon. Unlike a black hole, which pulls everything toward its singularity, a white hole violently expels matter and energy from its core. Think of it as the reverse of a cosmic vacuum. Instead of sucking, it explodes. Constantly, relentlessly. The moment you try to approach it, your path bends away. Gravity repels you. Space itself refuses your entry. This isn't science fiction. This is what happens when you run Einstein's equations backward in time. The math says it's possible. The universe says it hasn't shown us one yet. And that's the mystery. Some scientists believe our entire universe began as a white hole. Not a tiny point, not a singularity hidden in darkness, but a violent, expanding burst of space, time, matter, and energy erupting from a region where physics, as we know it, broke down. In this view, the Big Bang wasn't the start of everything. It was the moment a white hole opened. All the stars, all the galaxies, all the atoms in your body, they weren't created from nothing. They were ejected from somewhere else, from a place beyond our space-time. This idea isn't new. It was proposed in the 1960s. It was ignored. But now, with new theories of quantum gravity, it's returning. If the Big Bang was a white hole, then we are all fragments of something older, something hidden, something we haven't found. There's another possibility, that white holes aren't alone, that they're connected to black holes through tunnels in space-time called wormholes. Imagine a black hole swallowing matter at one end, and at the other end, a white hole blasting that same matter back into another part of the universe, or maybe another universe entirely. This is the idea behind the Einstein-Rosen bridge, a theoretical corridor linking two points in space or time. But here's the problem. Even if such a tunnel exists, it would collapse instantly. Any particle entering it, even a single electron, would trigger its destruction. The structure is too fragile, too unstable. So while wormholes make great movies, they don't survive long enough for anything to cross. Still, the thought lingers. Could a black hole and a white hole be two ends of the same cosmic pipe? One feeding the other? One hiding the other? In 2006, astronomers detected something strange. A flash of gamma rays, incredibly bright, incredibly brief. lasting just 0.2 seconds. It came from a region of space where nothing should have been. No star, no supernova, no known source. It didn't match any pattern of known cosmic explosions. Then, in 2014, another similar signal appeared. And again in 2018. These events were named short gamma-ray bursts with no afterglow. They didn't fade. They vanished, like something had exploded and then disappeared completely. Some researchers suggested these might be the final moments of a white hole. A sudden release of energy trapped for eons, finally breaking free. A mini Big Bang, a little bang. If true, this would be the first observational hint of a white hole. Not proof, not confirmation, but a whisper, a signal from the edge of known physics. Here's why white holes are so hard to accept. They violate a simple law: entropy. Everything in the universe moves toward disorder. Stars burn out. Galaxies drift apart. Energy spreads thin. But a white hole? It creates order. It spits out perfectly organized matter and energy like a cosmic factory printing universes on demand. That's the opposite of how nature works. And there's another issue. If a white hole exists, it must remain empty. The moment even one atom falls into it, the whole system collapses. No more explosion, no more output, just silence. So for a white hole to exist today, it must have existed for billions of years without ever being touched, without ever being contaminated. That's impossible, unless it's not in our universe at all. The most serious attempt to rescue the white hole comes from loop quantum gravity, a theory trying to merge general relativity with quantum mechanics. In this model, black holes don't collapse into infinite points. Instead, they bounce. When matter reaches extreme density, quantum pressure kicks in. The collapse reverses. The black hole becomes a white hole. And everything it's swallowed, all the stars, all the planets, all the light gets spat back out. Not into our universe, into another. Maybe one with different laws, different constants, different physics. This theory suggests white holes aren't rare. They're inevitable. Every black hole, over unimaginable time, transforms into one. But the process takes trillions of years. So we won't see it happen. Not in our lifetime, not in our galaxy. But if we could look far enough, deep into the past, we might find the echoes. In 2004, scientists using the WMAP satellite found something baffling. A vast region of space near the constellation Eridanus, colder than it should be, by 45%, almost 1 billion degrees below average. No stars, no galaxies, no radio waves, just cold, empty, silent. Later, the Planck satellite confirmed it. This cold spot defied explanation. Was it a statistical fluke? A flaw in the data? Or something deeper? Some theorists proposed, what if this patch of space is the exit point of a white hole? An ancient one, long since exhausted, but its gravitational imprint remains. A scar left behind when matter was violently ejected from another dimension. The temperature drop? The missing energy? The absence of matter? All signs of something that once erupted and then vanished. We don't know, but we're looking. White holes are not proven. They are not observed. They are not listed in any catalog of celestial objects. But they are not fantasy. They are mathematics made visible. They are the echo of a question we haven't answered. Is the universe symmetric? Does every force have an opposite? Does every ending have a beginning? For now, white holes remain ghosts in the equations, beautiful, elegant, and terrifying in their implications. If they exist, they rewrite everything. Time flows differently. Universes connect. The Big Bang is not the origin, just a doorway. And perhaps, just perhaps, somewhere beyond the veil of our reality, a white hole is still exploding, spitting out stars, spitting out worlds, spitting out life. And we're standing here on a planet made of its leftovers, wondering if we're the result or just the beginning. We hope this journey ignited your curiosity. Stay with us as we venture deeper into the invisible architecture of the cosmos. Subscribe and join us for the next discovery.